Hello, Math 2. This is Mrs. Bricky, and the video here is for Unit 9, Lesson 3. We will be doing the quadratic formula today with complex answers. So we have used the quadratic formula in the past. You should be familiar with it. Most of you are what I would qualify as an expert with the quadratic formula. So remember, the quadratic formula tells us that if ax squared plus bx plus c is equal to 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this first little equation, I have my a value is 1. So watch out for 1s because they're invisible. They're there, but they're not there. So watch out for those. Our b value is negative 8, and our c value is 10. So that means our two solutions to this quadratic equation are x equals, it's at negative 8 plus or minus the square root of negative 8 squared, especially when your b is negative. Be very careful to put it in the parentheses like that, minus 4 times our a value multiplied by our c value, and that's all over 2 times our a value. So, we can clean up the negative 8. We know that is just a positive 8, and you may have even written that that way from the get-go. And our denominator is 2 times 1, and that is just 2. So we can use our calculator to help us evaluate that root. If you just simply ask your calculator about what is this number inside that root, your calculator will tell you that that number is 24. The square root of 24 is the same as 2 root 6. So we can replace that root 24 with a 2 root 6. And we're almost done. We can actually simplify our fraction here because 8 is divisible by 2 and 2 root 6 is divisible by 2. So if we reduce that fraction, 8 divided by 2 is 4, and 2 root 6 divided by 2 is root 6. And so we got those two answers, and those are real roots. Those are real answers. So that's what we've done in the past with the quadratic formula. Today, our focus is going to be on quadratics that have complex solutions. So let's find the roots of this second equation. So it's almost the same. Our a is still 1, our b is still negative 8, but this time our c is 20. So x is equal to, and our setup is almost the same. That's going to end up being a positive 8 because it's a negative 8 plus or minus the square root of negative 8 squared minus 4 times a times c. Our c is different this time, all over 2a. So we have 8 plus or minus some root over 2. So if we evaluate that root in your calculator, you will get that number inside the root is a negative 16. My handwriting is not great today. I'm sorry. So that if you typed the root in with that, you would just get a domain error. So just be really careful with what you're doing in your calculator. On this one, it probably would have been okay if you typed the root in and your calculator would have taken you straight to the 2 root 6. But on this one, if you type the root in, you're going to get a domain error. If you get a domain error, don't panic. Just type in the expression without the root because your calculator can't simplify complex roots, but you can. The square root of negative 16 is an imaginary number. This will be 8 plus or minus 4i. Root negative 16 is 4i. And that is, of course, divided by 2. So we just need to finish up by simplifying that fraction. 8 divided by 2 is 4 plus or minus, and 4i divided by 2 is 2i. So this quadratic has two imaginary or complex roots. So before we worked with real roots, and now we're going to have some non-real roots. And that's okay. Just know that when you're simplifying that radical, if it has a negative underneath it, you're going to have an imaginary answer. So when we're working with the quadratic formula, simplifying your answer is sometimes the most difficult part. So I wanted to just practice simplifying some complex solutions, and then we'll do a couple more examples together. Okay, so if I have 10 plus or minus negative 36, square root of negative 36 all over 2, I've got to think about that root first. The square root of negative 36 is the same as 6i. So this is 10 plus or minus 6i divided by 2, and that would be 5 plus or minus 3i. Okay, our next one is 8 plus or minus root negative 432 all over 4. So if we simplify that root, the square root of 432 is 12 root 3. So this will be 12i root 3. It's imaginary, and that's all over 4. And we can reduce that. 8 divided by 4 is 2. 12i root 3 divided by 4 is 3i root 3. Now remember, when you're dividing something with a root like this, the only part that divides is that coefficient. The root stays the same, the I stays the same. It's the coefficient that we divide. It's kind of the same as having a 12x divided by 4, and that just becomes a 3x. The x doesn't change. We're just using the coefficient to reduce. Okay, another one here. We've got 5 plus or minus root negative 4 all over 3. Well, that root negative 4 is the same as 2i, and this is all over 3. Now, in this case, it's probably fine to leave your answer like this. This is not in standard form, but again, it would be okay if you left your answer like this. In standard form, our real part is 5/3, and our imaginary part is 2/3 I. So this is how we would write it in standard form. Okay, so here we have our last one. It's negative 3 plus or minus the square root of negative 144. Well, the square root of 144 is 12, so this is 12i. Now, in this case, the 6 and the 12 are definitely nicely divisible, but the 3 and the 6 are not. So I'm going to think about separating it into my two parts. It's a negative 3 divided by 6, and it's a 12i divided by 6. Well, negative 3 divided by 6 is the same as negative 1/2, and 12i divided by 6 is the same as 2i. So on this one, it is good to go ahead and divide it out. Negative 1/2 plus or minus 2i. If you left it like this, it wouldn't be the end of the world. Your answer is correct. It could be simplified a little bit. Another way you could write this is negative 1 plus or minus 2i. Oh my gosh, I can't even, sorry, I'm not writing it right. Sorry. Reducing a factor of 3, it would be negative 1 plus or minus 4i over 2. That's another way you could write this one. And you can kind of see the 1/2 and the 2i there. Okay, so we're going to go back to practicing with the quadratic formula. I'm going to skip this first one just because, videos can get nice and long. I'm going to go to this second one right here. So we've got 7x squared plus 14x plus 42 equals 0. So our a value is 7, our b value is 14, and our c value is 42. So x is equal to, it's negative, and then our b value plus or minus, we've got b squared minus 4ac, and it's all divided by 2 times a. So we've got a 14 on the bottom for sure. 2 times 7 is 14, and let's see if we can figure out what that root is. If we calculate that inside number, we get the square root of negative 980. So if we simplify the square root of 980, It is 14 root 5, but our answer is imaginary. So we have 14I root 5, and this is all over 14. And look at all those 14s. They definitely can reduce. So negative 14 divided by 14 is negative 1. And then 14I root 5 over 14 is I root 5. So here's our two solutions to that equation. So our next two problems are a little bit different than the last two. Hopefully when you look at them, you realize that the reason that they're different is because they are not equal to 0 at this point. So in order to use the quadratic formula, you need to have equations that are equal to 0. So we're going to add 10 to both sides of this equation. So we get 2x squared minus 2x plus 5 is equal to 0. So if we can identify our A, B, and C values, we can use our quadratic formula now. So we get x is equal to negative 2 plus or minus the square root of negative 2 squared minus 4 times A times C, and that's all divided by 2 times A. So simplifying a little bit, we've got a positive 2 on the top and we've got a 4 on the bottom. And our square root, if we calculate that, that is a negative 36. So we've got 2 plus or minus 6i over 4. 2 over 4 is the same as the number 1/2, and 6i over 4 is the same as 3/2 I. So this is our answer in standard form. This answer, in some cases it's okay. If you were doing a standardized test or multiple choice or something, it wouldn't be there. You would either see it like this in standard form, or you might see it reduced by a factor of 2 like this. Okay, one more of these. So again, we don't have a 0 in our equation yet. So we need to go ahead and move some terms around. We're going to add 310 to both sides of our equation, and we're going to subtract 2x squared. So we get 3x squared plus 78x plus 519 is equal to 0. All right, so if we use the quadratic formula to solve this, we've got our A, our B, and our C value here. X is equal to negative B plus or minus the square root of B squared, oh, that's a 78, minus 4 times A times C, and this is all divided by 2 times A. So we've got our negative 78. Our denominator is a 6. And let's use our calculator to figure out that number under the root. And 78 squared minus 4 times 3 times 519 ends up being negative 144. So that means this is negative 78 plus or minus 12i all over 6. And that reduces negative 78 divided by 6 is negative 13, and 12i divided by 6 is 2i. So those are our two solutions. Okay, so that really is like the big idea of the day, is to be able to use the quadratic formula to solve a quadratic equation even when the roots are not real. I do want to just do one more thing, and that is that we now know two methods for finding complex roots of a quadratic equation, the square root method and the quadratic formula. So I want to review the square root method with you, and then also you have the quadratic formula. So you want to use the square root method when your equation sort of has a vertexy form to it, when you have an x that is being squared, but you don't have any additional x's in the equation. That is a situation where the square root method is your best bet. So this one's actually ready for us to take the square root right now. We don't have any other steps to do. So I can square root both sides of this. Don't forget you have two solutions, a positive and a negative solution. So on the side over here, I have x plus 5/3. And don't worry about that it's a fraction. Your calculator can help you handle the fractions very well. It's just a number like any other number. Now, if you try to type in the square root of negative 41 over 9 in your calculator, it's going to give you a domain error. And if you try to type in the square root of 41 over 9 positive, your calculator is going to go to a decimal approximation. So I wanted to talk about how we can deal with the square root of a fraction. And that is that you can do the root of the top and the root of the bottom. And I put the negative with the 41. I would just put it with the numerator if you're doing this. So if I try to simplify the square root of 41, my calculator is like, oh, that's just a root 41. So the top of this will be an I root 41, but the square root of 9 is one that we know it's a 3. So our equation looks like x plus 5/3 is equal to positive and negative I root 41 over 3. So our last step is to subtract 5/3. And we're subtracting the real number 5/3. So I'm going to put it in front because we like our real part to come first, plus or minus I root 41 over 3. So that's our answer. So that's the square root method, and that's for situations where you have your binomial squared and no other additional x's in the equation. You may have some other steps like adding and subtracting before you take your root, but eventually you'll take the root plus or minus. Okay, and then the situation in which you want to use the quadratic formula is when you have an x squared term and you have a linear x term as well. So you want, of course, to make sure when you're using the quadratic formula that your equation is equal to 0 and you want it to be in standard form. So that minus 4x is going to get tucked right in between the x squared and the 10. And at that point, we could certainly do the quadratic formula with our a, b, and c value. So x equals negative 4. So that's going to be a positive 4. B squared minus 4ac. And it's all over 2a. So we've got 4 plus or minus. This root is 16 minus 40. 16 minus 40 is negative 24. So this is 4 plus or minus 2I root 6 over 2. That's 2 plus or minus I root 6. So those are our two answers to this equation. So just make sure that you're feeling comfortable with both of these methods. And that's our main thing for today, is to just to get you used to the quadratic formula with non-real answers, and then don't forget the square root method. All right, thanks a lot. That's the video for 9.3. Let your teacher know if you have any questions.